Welcome back to the classroom. My name is Mr. Wong. Today we'll be going through the 2010 HSC Physics paper, question 23. This is for Module 7, Inquiry question number 4. This is about light and special relativity. And the following image and question we're going to look at is on the principle of relativity. So with the question A here, where it says, why does the mass hang with the string at an angle to the vertical? So as we can see here, if we look at the angle theta here, we can assume that's there. Now, obviously, that can mean a couple of things. The train is moving towards the left-hand side like that, okay? And as it's moving to the left, it's caused the object to go backwards. The other thing we can probably also say is the fact that if I was standing inside the train and I looked up and I saw the mass there, I can see that there is a way of indicating which direction the train is moving. So what that means is this scenario that we have is a non-inertial frame of reference, or a non-inertial frame. So if that's a non-inertial frame, we need to come up with different ways of working out what could be the reasoning why it's non-inertial. So as we just said, the train could be accelerating towards the left. That puts the mass, or that forces the mass to accelerate to the right. That's one way. The other way that could be the case could be if the train was turning. So in this case here, let's say the train was turning, let's say if the train was turning towards the left, that could also deviate the ball to the right, and so on. And also, what was the other scenario that we had? So the other scenario that could be the case is if we were slowing down as we were moving towards the right. So as we slow down, or as we come to a stop moving towards the right, the original inertia of the mass would be to continue to move to the right, and that's where we get that. So those are the scenarios that we have. So why does the ball hang with the string at an angle? That represents that we are in a non-inertial frame. So the train is a non-inertial frame. Accelerating towards left, or could be accelerating to the left, decelerating, moving to the right, or turning around a corner. So there's that. And obviously in this context here, I would say left there. All right, so the next one we have is the string then breaks and the mass falls. So just draw that diagram back out again. So our train was like this, and let's say the train was moving like that, and the pendulum was like that. We're gonna cut it. Okay. Ooh. So we've cut the string, and we're trying to work out which direction the mass will fall. Now, technically speaking, if I try and draw a path, okay, the path would look like this. So the train is moving in that direction. My assumption will be pendulum is like that. The path taken, the pendulum is going to fall in this diagonal direction down like that. Okay. So it's going to fall in that diagonal direction. The reasoning, therefore, we need to explain is why that's the case. So there's actually two motions that's acting on the that's acting on my pendulum here. So what we have is we have gravity. Gravity is pulling the object down. Okay. And also, because the train is accelerating towards the left, okay, that means our pendulum also has a net force going towards the right. So the opposing force, you could say. So force opposing. So there's that. So under that circumstance, we have two forms of acceleration. We have one acceleration, which is due to gravity, and one acceleration, which is due from the tension of the string that was originally opposing the direction of that forward left motion. Okay, so that's why that was the case. That's why it's going to go directly down in a straight line direction instead of doing maybe like a parabola, if you so will, for a projectile motion, because there are two accelerations. That's why it gives you that linear diagonal pathway there. Okay, so let me just try and write something down for that. So the path taken by the mass is to go in a straight diagonal line or straight diagonal path down in that direction. I guess that's the easiest way of describing it. This is because it experiences the acceleration due to gravity and acceleration from opposing oh, my G's falling down. Opposing the acceleration from opposing the accelerating train. So there's what we have. Actually, let's just reword that a bit better. I can get rid of some of the G's. So this is because it experienced an acceleration due to gravity. That's the reason why it's going to go down. And the opposing force to the tension of the string, making it go in that direction. So as there are two accelerations in the, as there is an acceleration in the vertical and horizontal component, when they add together, it gives you a straight path. Okay, so as there is an acceleration in the horizontal and vertical component, the path goes that way. Okay, so that's how you would explain that question there. So hopefully that makes some kind of sense. In a way, it's quite similar to when we talked about projectile motion, in the sense that the reason why the pendulum keeps going down this way, one, it's partially because of its inertia. Obviously, when you cut it, that's the inertia that it was partaking in. So I guess you could also talk about the inertia of the mass. But the reason why the inertia is going in that particular direction is because of the acceleration it was experiencing from gravity and the acceleration component from, opposing the motion of the moving train there. So opposing the force, or opposing the, maybe we'll change that. So opposing and the acceleration opposing the train accelerating left. And that forces our mass to go to the right. Okay, so I might just fix that up a little bit because it's a little bit messy. Hence, mass accelerates towards the right. You could probably word it a little bit better than what I had here, but that's how you would do it there.